All right. Hello today. This is Cameron Smith from TechLogix, and this morning we're going to be looking at the 18 gig HDMI solutions from us here at TechLogix, the technology that's really tackling high bandwidth HDMI applications. Little bit of a reminder for who I am. And for anybody who's on the call that's kind of new to TechLogix, so I'm one of the partners here, and I deal with a lot of the different technologies and the different things that we're developing. And obviously, I've been with the company since the beginning. Speaking to the roadmap on specifically what we deal with, we do a lot of fiber optic technology here, which ties in very nicely, as we'll see today, with 18 gig HDMI signal distribution. And then we're also very heavy in the collaboration space, so technology that's used in meeting rooms, huddle rooms, boardrooms, things like that. So let's start by looking at what is HDMI, specifically 18 gig HDMI. And a lot of people call this different things. So some people call it 4K 60 444. You know, I get a lot of calls from different designers and integrators, different end users who are integrating systems and say, hey, look, I need compatibility for HDR, or I need to make sure my system can handle 444 HDMI 2.0. And all of these things do fit into the 18 gig kind of threshold in this 18 gig data range. However, it's not necessarily telling the whole story. So when we say HDMI 2.0, it doesn't necessarily infer that we're talking about something that supports 18 gig of bandwidth. It doesn't necessarily infer we are supporting all of the different 4K spectrums. So it's really important as we kind of look at what technologies out there, especially from different manufacturers, that we really understand what does support the latest and the greatest versions of HDMI. So several people may have seen this chart before. This is a chart I really like. I use it in a lot of the different training materials and our literature, and we have white papers around it. But this chart shows how 18 gig, and more specifically HDMI, can be broken down based on the different signal components. And what we see here is simply by saying HDMI 2.0, version HDMI 2.0, or simply by saying I need to send a 4K signal, doesn't really tell the whole story. We need to break those signals down into the various components. So what is our color bit depth? What is our frame rate? Are we enabling HDR? So we put all of these things together, and we see that the data rate, or the bandwidth, the thing that we talk about when we say 10 gig HDMI or 18 gig HDMI, can really be affected. And different products fall in different areas of this spectrum. Most manufacturers are engineering and manufacturing products to either support 1080p, so this is a lot of the legacy technology, 10 gig HDMI, and 10 gig HDMI can support 4K 60, can support HDMI 2.0, but it's not necessarily going to give you the frame rates, the chroma subsampling, the color bit depth. It's not necessarily going to support HDR. When we step into products that support 18 gig, we really have the capability to support everything that we're trying to send, whether it's a 1080p signal or really an HDR signal or a high bandwidth, high data rate signal, which is very common in today's applications. So now let's look at some of the technology. This is a little bit of a brief overview, a shorter webinar for folks who've been on this before. Let's start with the splitters. These we consider very high run rate demand products. We do a lot of this type of equipment. Certainly not necessarily an area that we are unique in or we specialize in. However, we do bring some unique slants to our technology in the fact that we are building technology that supports 18 gig. So both of the splitters that you see on the screen right now, both of these support that full data rate that's going to handle all of the HDMI signals that we're working with today. They are very slim line, you'll notice as you look at these pictures. They're thin. They're made to be mounted behind screens, mounted under tables, in racks. They're easy to hide. They come with that mounting hardware that we need to secure the product. And then other things that we look at, the demand and the need to manage EDID. So when we're dealing with a 1x2 splitter, so a single HDMI input, multiple HDMI outputs, or a 1x4, one HDMI input, 4 different HDMI outputs. These products need to be able to manage multiple different displays. And for that reason, these do have automatic EDID built into them. So essentially, whatever device or whatever display is plugged into these splitters, first, that's the EDID information that is transmitted to the source. Now, if we power cycle the device while multiple outputs are connected simultaneously, it's going to default to channel 1. So these devices are smart enough. These splitters are smart enough to handle multiple displays and really go into these kind of flexible real-world installations where we may be working with a lot of different materials. Now, we also get into some of the bigger products when we're going into more of a digital signage application or a retail application or sports bar application. We see a lot of products like this going into those scenarios. And that's because we're splitting a single HDMI input to 8 HDMI outputs. And I should mention that the 1x2, the 1x4, and the 1x8, you can daisy chain all these products. So you can stack them together to really tackle an installation that has more than 2 outputs or more than 4 or even more than 8 outputs. But we do make these in various sizes. The biggest difference between the 1x8 and the 1x2 and the 1x4 is that the 1x8 has a rotary dip switch that allows us to hard lock that EDID signal into the device. And that becomes more important as we're starting to get a lot of different channels and or stacking multiple splitters together for these very large distribution systems. You want to ensure that all the different displays are communicating properly with the sources. And by locking the EDID down, by forcing it to say, hey, look, I'm going to be 1080p, or I'm going to have HDR enabled, or whatever the signal characteristics are necessary for installation, we can hard lock that into the device so everything's communicating properly. That's all part of this technology. It's something that does differentiate TechLogix. We tend to be a little bit more of an engineering-focused organization. Now, that same form factor that we're looking at for the splitters is also used in the switchers that we're dealing with here. One of our most popular units that does support 18 gig HDMI is our 4x1 HD2 that you see on the screen right now. This supports the full HDR, the full capacity and capabilities of that 18 gig data rate signals. And it also is built for a variety of different environments, whether we're dealing with residential type applications where we're going to have some sort of third-party control system that's switching via IRRs 232, but also the commercial installations. And we do see a lot of commercial installations using this technology because it supports automatic switching. And what we mean by automatic switching is this device, because there are 4 different inputs, you could connect 4 different laptops to it. You could connect 4 different tablets or whatever the sources may be. This senses when somebody connects or turns on the device, and it will automatically switch to that channel, making it live. And if somebody new comes in, plugs into the switch or turns on their laptop, it will automatically switch to their live source. Now, this can be overridden, of course, if we want a manual control system. We see in the real world about half the installations just go with the auto switching because it's hands-free, it's easy, very high degree of user satisfaction. But then the other half of the installations want some sort of controller to tell this device what to do. Popular device. It is something that has a lot of application out there, and it is something that, again, is designed for that real-world installation with being mounted behind displays or mounted under tables, hidden in a really tight, low-profile type deployment. Now, 18 gig, a lot of people who are familiar with fiber optics, they know that that's the way to go as we're future-proofing installations. They know that fiber is becoming more necessary for these high bandwidth applications and installations, but we can use twisted pair to send 18 gig HDMI signals. Now, even though twisted pair maxes out at 10 gig, we are developing and we are manufacturing technology that will take that 18 gig signal, compress the color space. So essentially, we're taking the 444 color space in that HDMI stream. We're compressing it down to 420. We're getting that signal under the 10 gig threshold. We're transmitting it over twisted pair, and then we're decompressing it on the other end. So this is built into a couple of products we'll look at here in a moment. The top selling one is the TP40 HDC2. And the reason it's the top selling is because it's kind of the basic entry-level product that doesn't have all the bells and whistles, but speaks to about 80% of the installations out there. It is delivering HDMI extension. It is extending that 18 gig signal up to 40 meters or 130 feet, but it also does handle 1080p and 10 gig HDMI, and it will drive those signals up to 70 meters or 220 feet. Like most twisted pair extenders that are available from us, that are leveraging things like HDBaseT technology, you only power the system at the send or receive, your choice. And then we're also building the IR and RS-232 embedding into that stream, so we're distributing those control signals with the HDMI. Now, as we step up into the larger brother of this product, the TP40 stepping into the larger brother, which is the TP100, we see a lot more functionality and capabilities. It's simply a bigger product employing different processing to do more. And what we get out of the TP100 HDC2 is the capability to send not only HDMI, IR, and RS-232, but also Ethernet. So as we're incorporating more streaming devices, Apple TVs, Rokus, a variety of streaming devices, web-enabled devices, we can connect those to this TP100 because it has an Ethernet channel. Now, the other thing that we're doing is we have a different circuit in here that allows us to transmit signals, especially those high bandwidth 18 gig signals, longer distances. 18 gig HDMI, so things like HDR, that 4K 6444 signal will go up to 100 meters or 330 feet. We are also handling 10 gig. We are also handling 1080p. And those signals are also going 330 feet max distance over standard twisted pair cabling. Now, one of the other major advantages that this product has is built-in ARC, audio return channel. So essentially, we're taking audio from the display and we're transmitting it over the twisted pair through a back channel and then distributing it out at the transmitter. So from the receiver, from the display, back to the transmitter, and then de-embedding it from that HDMI stream. And we have the capability in this product to select whether we want that back channel audio to be output as digital through a Toslink connector or analog through an 1/8 inch connector. So there's a lot of functionality built into this product, whether we're doing a residential installation and we need digital audio ARC breakout, or we're doing a commercial installation and say we need to feed audio to an amplifier or some sort of audio reinforcement or recording system. This product has that all built in. So a lot more functionality. It simply does more with the distribution of 18 gig HDMI. Now, this gives you a little bit of a view on what I'm talking about with the audio breakout. So you see this little adapter on there that plugs into that audio input channel. And you might see on top of the device, it's labeled analog or optical. Essentially, what this adapter does is it converts that channel from analog to digital once we flip a switch. And for this reason, we can support things like 1/8 inch or 3.5 millimeter audio connections, as well as the Toslink digital connection. And this little adapter does ship with the unit. Now, kind of moving on here, we step into the fiber world. And these tend to be the most popular products that TechLogix is known for today. This is the TLFO2 HDC. This transmits our 18 gig HDMI signal over fiber optics. And those fiber optics can drive the signal up to 300 meters, or about 984 feet, just a shade under 1,000 feet over multi-mode. And then if we use single mode through a swappable SFP module, we can drive those signals over 10 kilometers. So fiber is really allowing us to take these high data rate, high bandwidth signals very, very long distances. And much like the twisted pair extenders we just saw, you see that we have built-in control. So these support RS-232 and IR. It embeds that onto that HDMI stream. We have the ability to compress our color space, so we can get that high bandwidth signal down to go through an environment, patch panels or different equipment in line that requires a 10 gig signal for distribution. So there's a lot of flexibility built into these fiber extenders. And instead of twisted pair like what we saw, we are using duplex LC. It does require power on both ends. Fiber does not transmit power. And again, we have the ability to really drive those HDMI 2.0 and HDCP 2.2 signals very, very long distances with very, very high integrity. This little view here gives you a look at what that SFP module looks like. And the way these fiber extenders work, at least in the case of the TLFO2 HDC, is you swap out these SFPs depending on the different cable that you're using. So if we're using multi-mode, which is what these are come out of the box made for, we use the SFP in the product. Now we can pop that module out, pop in a new module, and the product's just been adapted for single mode fiber optic distribution. So a lot of flexibility depending on the environment we're going into. Now, the next product we want to look at is the TLFO2 HDC2. Very similar to the one we just looked at, with the difference of an audio return channel and onboard connectors. So because this has onboard LC connectors, we can't swap those SFP modules, but it does handle fully uncompressed digital video up to that 984 feet or 300 meters. Now, the last product we really want to look at today is the 18 gig HDMI over IP. This is another area that we're very active in. It's an area that we certainly are very different than a lot of other manufacturers in. And essentially, we are delivering that high data rate, high bandwidth performance over a network. And there's different products or different parts of the system that go into making this possible. Obviously, there's encoders, there's decoders, control boxes, and then a software platform which ties it all together, much like a twisted pair-based AV over IP system. However, because we're using fiber, and in this case we are using duplex LC fiber, it allows us to do a lot more with the product. So we are tackling 18 gig HDMI. We are tackling things like seamless switching, video wall processing. We do have Ethernet capability and Ethernet streaming all built into these products. But the big thing is, as we look towards the future, as we look toward what's coming around the pipe and can we tackle these high bandwidth signals, this AV over IP system really handles that, and it's designed to handle that. So we can get a little bit of a look on where we really excel, and it is in the latency, it is in the max distances. I mean, these products can be distributing signals all the way up to 30 kilometers, and the fact that we are handling, again, that high bandwidth signal. So just to kind of summarize here, we here at TechLogix We do a lot of different things, from fiber optics to collaboration technology, as I mentioned, but we are a very forward-thinking company. We do tackle many of the basic components for signal distribution. We are tackling that with 18 gig, whether we're doing splitters, switchers, even twisted pair extenders, fiber extenders, and AV over IP. So with that, I appreciate your time today. My information is on the screen. If you have any questions, you need to get a hold of me. And we will be sending out some information on these products and solutions shortly after the webinar. So thank you again for your time, and I hope you have a good day.